Okay, in this particular video, we will do an example of the null space. Okay, we'll take a matrix and we will determine its nullity, null space, and the basis for null space using the concepts we have studied earlier in 4 fundamental subspaces. Right? So let's take a matrix A as 2 1 1 4 3 1 6 0 6 8 5 3. So this is our 3 cross 4 matrix, and we want to find the null space of A. This is what we want to find out. Okay. Now, a null space of A, already know null space of A means you want to find out the values of x for which Ax is equal to 0, the solutions of the homogeneous system of equations. These concepts we have discussed in detail earlier, so you can watch those videos. We'll discuss the application of the concept in this particular video. So the first thing we have to do is reduce this matrix into the reduced row echelon form. So let's do that. So the first row operation we can do is just halving the first row. So R1 by 2, and from R2 we can subtract, and from R3 we can subtract R1. We will make zeros like that. So R2 minus R1, R3 minus R1. Let's do all these operations together. This is 1, 2, 3, 4. This is 0. You subtract R1 again. So 3 minus 2 is 1. You subtract R1. This is minus 6. You subtract R1. This is 1. Now you subtract R1 again, which is 0. Okay, you are already halving it. The halving is first and then you are subtracting. Okay, then 1 minus 2 is minus 1, and 6 minus 3 is 6 minus 3 is how much? 6 minus 3 is minus 3, and 3 minus 4 is minus 1. Right, you get it here. Now we want to make this element to 0, so we just add R2 plus R3. Okay, then this will become 0. R1 is unaffected, so it is written as it is. R2 is unaffected as well. 1 1 minus 6 1. R3 will be a 0 here. Minus 6 plus minus 3 is minus 6, minus 3 is minus 9 here, and here you will get minus 1 plus 1 is 0. Okay, now the next step is we will make this minus 9 to 1. Okay, which is you multiply it by 1 by 9, minus 1 by 9. So when you do that, you will get 1 here. 1 2 3 4 0 1 minus 6 1 0 0 1 0. Okay, so that's it. We have done this into row echelon form. Now for reduced row echelon form, let's make this 2 as 0. So to make this 2 as 0 will be R1 minus 2 R2. Let's do this. Let's write the matrix here. So 0 1 minus 6 1 is here, 0 0 1 0 is here, and this is 1, this is 0. Okay, and R1 minus 2 R2 is 3 minus 12, which is 3 plus 12, that is 15, and this is going to be 2. You want to make this 0, so how do you make this 0? Just 2 times again, and you will get this as well as 0. Alright, so this is what we got here. So that means what are our equations that we get here? Just a second, I'm sorry, there was a little bit of a lag with my pen. Okay, the pen had lagged, but it's fine now. Okay, so now let's we have got these equations, right? We have got these equations here sorted out. So now what we have to do, our final row echelon form, we will just convert this into, we'll just half it. So this will become 1 0 9 2 and 0 1 minus 3 1 and 0 0 0 0. Okay, so this is basically our reduced row echelon form. This is the final form that we wanted. So now you see what is the nullity. The nullity is the number of free variables. So you can see these two are the pivots. So there are 2 free variables, x3 and x4. So x3 and x4 are free variables. That means the nullity is 2 and the dimension of the null space is 2. Okay, now how do you find the basis for the null space here? You put x3 is equal to t and x4 is equal to u. Okay, so write the others in terms of this. So your x2 can be written as x2 can be written as, how much can you write x2 as? X1 you can write as minus 9t plus 4u, and x2 can be written in the same way as well, as 3s minus t. We'll just call this s and t. Okay, we'll just call this s and t. Now what you do is, first you put x1 is equal to 1 and x3 is equal to 1 and x4 is equal to 0, you get one vector. And then you put x4 is equal to 1 and x3 is equal to 0, you get another vector. And the span of those vectors v1 and v2, okay, this v1 and v2 basically are the basis for null space of A, and the span of the basis of the null space of A will give you null space of A itself. Because see, you should keep a note here that a vector space can be written as a span of its basis vectors. That is what the role of a basis is, right? When you take a linear combination which is the span of the basis, you will explicitly write the vector space. So that's what you do here. I would leave the computation up to you, but this is the concept that you have to use to get the null space and nullity of a given matrix, right? Null space is one of the 4 fundamental subspaces. We have discussed all the spaces in detail earlier videos also, so you can take this and you can watch those videos also, and that will help you to revise. Thank you.